Okay, now you'll notice that we're going to do quiz review unit number 1. All right, so now what I'm going to do, or what you need to do, is you need to put this data, data A and data B, into the calculator. And I'm going to show you a video here in a second that does that. All right, so let me undo that. In fact, I'm going to do this right here and get rid of that. All right, so now notice one of the things it says is you need to round to the nearest tenth. That's this little part right here. It says round to the nearest tenth. And you're going to make a stem and leaf plot. So that is very important that you follow instructions. And then it says it wants you to comment on the shape and distribution of each distribution. Okay, so this is what we're going to do. Let me go ahead and delete that real quick of what I just wrote down. All right, now let's go ahead and play the video so I can show you what I mean by that. Okay, what we're going to do is we're going to show you how to put data in the calculator. And L1 is my data A, and L2 is my data B. Now, I don't know if you can see that cursor above. I'm going to go ahead and put this in order, so I'm going to hit my stat button, which is what's highlighted in red there. I'm going to go down to number 2, which is sort, so I'm going to hit number 2. And I'm going to choose second L1, which is second 1. Notice that the red popped up. And I'm going to close the parentheses and I'm going to hit enter, and it's going to say done. Now, that means my list 1 is sorted. So I'm going to do the same thing with list number 2. So I'm going to hit sort, so I'm going to hit stat again. I'm going to go down to sort. I'm going to hit second number 2, list L2. And now list 2 is sorted. Now I'm going to do the same thing with 3, 4, and 5, but I'll go ahead and put that in later. But what I want to do is go ahead and hit stat. Alright, now I want to go back. Notice these are now in order. So this will make it easy for you to create a stem and leaf plot. Now, first of all, what I'm going to do is I'm going to show you how to go about my data. So I'm going to go to stat. I'm going to hit calc, which is my arrow over 1, and I'm going to hit 1 variable statistic. Now notice I'm just going to hit enter 3 times because this is list 1. Now for list 1, there's my data. X bar is going to be 7.5 or 7.49, so that's your average for list 1. The standard deviation is 2.03, and if you arrow down, you will see your 5-number summary, which is 3.1, 6.1, 8.1, 9.1, and 9.3. Now, that gives you the 5-number summary and the average and standard deviation for list number 1. Now, if I go back, stat 2, I'm going to go back to calc. I'm going to do 1 variable statistic, but now I want list number 2. So I'm going to hit second, list 2. Now change that to list 2. I'm going to hit enter twice, actually 3 times. And there is 7.51, so the average is a little different. The standard deviation is 2.02. And then, of course, my 5-number summary is as follows: 5.3, 5.8, 7, 8.5, and 12.5. And that's the data you're going to see here in a second. Now again, let me remind you, it does say put the round to the nearest tenth and then make a stem and leaf plot. So that's what I'm going to do. So I'm going to put this over to the side. Now I want you to notice this. Notice a couple of features here. All right, let me go ahead and make this a dark blue. If you notice here, I put A on this side, B on this side, and I made a back-to-back stem and leaf plot. All right, now these are all rounded to the nearest tenths. Now, also notice here's a key. 3.1 represents 3.1. That's what I wrote right there. And 12/5, that represents 12.5 to this side. Notice what side they are on. That lets you know how to read this. Like this would be read as 5.3 or 7.7, 9.1, so on and so forth. So make sure you are aware of the key and how to label this. All right, so now, if you notice, here's my average for A, here's the standard deviation for A. Here's my average for B, my standard deviation for B. Now, I want you to notice something.
the average is the same. The standard deviation is the same. So it says to describe or make a comment on the shape of each distribution. Well, if you notice, if you look at the shapes, let me go ahead and turn this to the side. All right. Now, if you notice what I'm about to do, this shape right here, well, if you take a look at that, it's kind of skewed to the right. And then, if you take a look at, let's turn it around this way. Now, remember, this is reverse. So if I look at this one, this looks skewed to the right, but if you were to flip it over, because it has to go from least to greatest, it's actually skewed to the left. So in reality, it should be this way. Okay? Now, look what the description says. While both have the same average and standard deviation, data is clearly skewed to the left, and data B is clearly, or data set B is relatively symmetric with one high outlier. So what it's saying is this part is relatively symmetric, but it has one really high outlier. And that's how you describe the data. Now, for number 2, I'm not going to go through the computer segment on showing you how to input it and finding all your key data. Instead, what I'm going to do is I'm going to concentrate on question A and question B, where it says compute the 5 number summaries for the weight gains of 2 groups of chickens or chicks, then make box plots to compare the 2 distributions. And then what does the data show about the effects of the new corn? So we want to know the effects of the new corn compared to the normal corn. And then we're going to compare the distributions of the 2 types. Now, after you put the data in the calculator and you sort it, you can do a couple of things. And this is what you can do. Let me minimize this, pull it up to the top here. If you look at this right here, here is my stem and leaf plot. Okay, now notice this right here on the left, this is going to be, this is 18, or excuse me, this would be 8. So notice this is 180. This is 27. This is 28. So what do you think we did in this case? Well, if you look at the data, please look. Now, if you notice, this says 18. Well, the only number that's close to that is this 175. Well, what we did is we rounded everything up to the nearest tenth. So if I were to put 180, we simply just drop the 10, all right, or drop the 0 and made that 18. So that actually represents 180. Now, if you look at the key, let's go ahead and take a look at the key real quick. 4-5 means 45. 4-6 means 46. So if you'll just add a 0 to the end of it, that's what we're referring to. That would be 450. This would be 460. And we rounded it up. Okay? Now, with that being said, let's go ahead and take a look. Let me go ahead and erase all these other things. There we go. Now, I don't want to erase that. All right, so now, notice with this right here, notice the outlay. That's skewed to the left, clearly. Well, if you notice this one is pretty much symmetrical, okay? Now, let's go ahead and minimize that, or delete that. I just want to, no. All right, so now I'm going to get rid of that right quick, and I'm just going to throw that off to the side. We don't need that anymore. Now, what I do want to know is, or watch, is this. I created a box and whisker for each one. This is my normal corn. This is my new corn. Okay. Now notice they seem to be relatively symmetrical. This one might be, the one down here might be a little bit more to this side, but for the most part, it looks pretty symmetrical. Okay. Now we'll get to the description here in just a second. Notice, make sure you label everything. All right. Label your 5 number summary. Now, your standard deviation is 50.8 on the normal corn, and it's 66.6 on the new corn. So we're kind of putting all of our data out there, all our eggs in the basket, so to speak. That's funny. All right, so now what I'm going to do is I'm going to delete all that. Now, once we have all this information down, let's look at this. So now here's my averages. Now look at my average. My average is 366.3 grams for the normal corn, and then the new corn is 391.95 grams. Obviously, there's a weight gain. All right, so now let's go ahead and erase that real quick. And then let's get to the description. Now, on the description, this is what you could have written. Now, I want you to notice, I'm going to put this off to the side, and let's see if you can pick up on this. It says, on average, let me go ahead and do this real quick. All right, so on average, the chicks given the new corn gained more weight. So you're making a comparison there than those given the normal corn. It says 4 of the 5 parts of the 5-number summary. So here's your 5-number summary, the Q1, the median, the Q3, and the max. So 4 out of the 5 of them were bigger for the new corn over the normal corn. So notice what they're talking about. If you take this off to the side, let's look at the 5-number, or let's look at the box and whisker. Notice what they're talking about. Here's the normal corn. The new corn is bigger. The Q1 is also bigger. The median is also bigger. Now, this one is bigger as well, and this one, actually, on all of them, they're all bigger. So your 5 out of 5, really, are larger than the normal corn. Okay, so you can make that comparison that way. Let me go ahead and get rid of this real quick. All right, so now I'm going to drop this off to a second. Now let's see what else it has to say. Now it did say the average was also larger for the new corn than the normal corn. So the average went from 391 to 366.3. The distribution of the weight gain was relatively symmetric, and the distribution of the new corn is skewed to the left due to the outlier of 175. So if you look at that, let me pull this out of the way. Now let's look at that distribution here. Now if you notice how this is relatively normal, but if we include this, it kind of pulls it to the left. So that outlier kind of skews the data to the left, and that's what it's talking about. Okay? Now, it does go on to say this. The distribution weight gain was relatively symmetric, and of course the new one, it was skewed to the left. It went on to say, notice this right here is proving that there is an outlier. So by doing this right here and plugging in your information, anything less than 273.5 is a outlier, and it's larger than 175. So we just proved that 175 was an outlier. It says both distributions have relatively similar spreads, although the new corn's standard deviation is elevated due to the outlier. So remember, your outlier affects the average. It also affects the standard deviation because they're tied together. Notice 50.8 as opposed to 63.5. 50.8 and then 66.6. And then, of course, the new corn had a IQR of 366.5, and then the IQR here gave a totally different number of 63.3. So basically, in a nutshell, that's how you go about cussing and BS in statistics. I know this is a long video, but it's well worth watching the entire thing.